So welcome dear students. So today's session we'll be discussing about an combinational circuit. So what exactly are combinational circuits here? So when we speak about the digital circuits, now these digital circuits are classified into two different types. One is called as a combinational circuit and the other is called as a sequential circuit. So what are combinational circuit? If the output of the circuit is depending only on the present input, now such type of circuits are called as a combinational circuit. If the output of the circuit is depending upon the present input and previous output, now such type of circuits are called as an sequential circuits. So the examples of combinational circuit, you have got adder, subtractor, multiplexer, encoder and decoder. Similarly, the examples of sequential circuits, you have got flip-flops, registers and counters. So today we'll be discussing about this adders and subtractor there. Okay. Now, the first combinational circuit that we are going to study is your adder circuit. So adder, as we said, that it's a combinational circuit which will add the input, and we know that whenever we add the numbers, our resultant will be sum and carry. So therefore, adder I can call it as a combinational circuit which will add the inputs and produces the output as sum and carry there. Now, depending upon how many number of inputs we are adding, an adder can be class are of two different types. One is called as an half adder and the other one is called as an full adder. So what is half adder? So half adder is a combinational circuit which will add two 1-bit data A and B and produces the output as sum and carry C out. Whereas similarly full adder is a combinational circuit which will add three 1-bit data to produce the output as sum and carry. So we'll start discussing about first half adder. Half adder, we said that it's a combinational circuit which will add two 1-bit data and to produce the output as sum and carry. So this is a block diagram. So here we have got two inputs A and B. It is half adder will add the inputs and produce the output as sum and carry there. So here, how do we add that one? So we are this half adder is a digital circuit. So we have got two inputs. Now since the inputs are two, I can have four possible combinations. So that is 0, 0, 0, 1, 1, 0 and 1, 1. So we'll add that one. So 0 plus 0. So sum is 0 and we know that the carry is not generated. So therefore carry is 0. So 0 plus 1. So sum is 1, carry is 0. 1 plus 0, sum is 1, carry is 0. 1 plus 1, so sum is 0 and carry is 1 there. So this is the truth table. What exactly is the truth table? Now truth table is a table which gives all the possible combinations of inputs and output there. So from the truth table, so I can get the expression for half adder. I can tell that sum is equal to S is equal to A XOR with B and carry C is equal to AB. So from this expression, I can draw the circuit diagram. So this is the circuit diagram of an half adder using the logic gates there. So this half adder I can also construct using only the NAND gate, and I can tell the working of an half adder in four different sentences. So that is when A is equal to 0, B is equal to 0, then sum is equal to 0 and carry is equal to 0. So these are the four possible combinations there. So next, coming to the full adder. So full adder, we said that it's a combinational circuit which will add three 1-bit data. So these three 1-bit data, I'll call it as A, B and C in the producer, the output as sum and carry. So this is the block diagram. So here you can see that in the block diagram I have got three inputs A, B and C in, and it is producing the output as sum and carry. So truth table, yeah, again, so truth table, all possible combinations. So this is the truth table of the full adder this. So from the truth table I can get the expression. So the expression as sum is equal to S is equal to A XOR with B XOR with C and carry is equal to C is equal to AB plus C in into A XOR with B. So from this circuit, I can draw the circuit diagram. So this is the circuit diagram I will be drawing. Now this is the circuit diagram for a full adder there. Okay, so here you can see that based on the expression, I am trying to draw the circuit diagram. I'm not going to go in detail like how we got the circuit because I'll assume that so we have the basic knowledge of digital electronics to how to know how to write the circuit using the expressions there. So this is the circuit diagram of an half adder using a basic logic gate here. So half adder, sorry, full adder. So full adder can also be implemented using what you call only the NAND gates. So we'll not go in detail about this one. Okay, so this is the working. The way we are speaking about all the eight possible combinations about the full adder. Okay, now so next subtractor. So subtractor, we said that it's a combinational circuit which will subtract, like how adder was adding the inputs. Subtractor will subtract the inputs here. So once again, depending upon number of inputs we have got half subtractor and full subtractor. So we'll discuss about this half subtractor and full subtractor in our next video. Thank you.